This is a second video in the ZiptieAI series. I am redoing this video on the 5th of July, 2024. So this video is to give an overview of what ZiptieAI is. In the previous video, you just skipped to getting into the Air ASAP, how to build a copter as soon as possible. So let's get started. This wiki explains why you need ZiptieAI. That's the first page we're looking at. The Missing Big Picture demo series. I started out on drones with no assistance. I was at home and I was trying to find out how do you work with drones, and I really couldn't find a website that really made it clear. Now there's a lot of websites out there that, they're really well done. They're very interesting presenters, professional bloggers. When you try to follow their directions, you run into problems. And those problems can take a lot of your time. Now, the closest thing I found, and also the other thing is about the YouTube videos, very few of them really give you the big picture. I mean, the really big picture of how drones work and all that. So the closest thing I found was, this is truly a brilliant series, Intelligent Drone System Overview, a YouTube series from Intelligent Quads. It took me about 2 months to get through that video series, and I documented what I did. But that video series really gave me, how would you say, it really gave me the real insight into what drones are, how they work. Now let me give you an example. I redid a lot of the documents for that series. And it took me a couple months because it was dated as about 5 years old. And so I ran into a lot of problems. But what I did eventually was I created my own version. And if you look on the right here, you'll see that I documented every step. And I went through this several times. So this is how I do documentation. Now, this is still difficult to do because, every time I go through it, something is different. But from start to finish, I document it. And that's a core goal of ZiptieAI, is to have updated information that provides the big picture, like this wiki provides the big picture. Then you go into the Word documents for the details. And this YouTube provides the highest level picture of the wiki and the documents. So anyway, the Missing Picture demo series. I could never find that. That's what I'm trying to do with ZiptieAI, but it's a work in progress. Open source software often means chaos. And chaos is not an exaggeration. There's a very good YouTube video from Painless 360 where he explains why open source projects fail, or they just die a slow death. And somewhere else somebody said the key thing about open source, the developers are volunteers, so treat them with kid gloves. And that's so what happens with this is you get a lot of documentation that just doesn't have the information there. And an example of this is when I was trying to figure out how to do this RC receiver for the first time. This was a nightmare, just unbelievable. It was so complicated, the documentation was so bad. And there was no diagram like this. This is a diagram I put together. No diagram of the big picture. What are we trying to accomplish? And this is a diagram that shows the chain of configuration you have to go through to get this working. The goal here is to get those stick inputs into this flight computer that will then change the way the copter flies. and it's not simple. And you have YouTube experts provide limited info. And the reason they do that, YouTube experts, the professionals, they work for manufacturers. It's their job. They're doing this to keep the manufacturers happy. So, and they're not going to tell you anything bad about their sponsors. And they will help you. They're more motivated to help you if you're a Patreon sponsor, which I recommend. But still, you're pretty much, I found out pretty quickly that these YouTube expert videos are usually missing a lot of information, almost always missing a lot of information. In fact, one time an expert admitted he almost gave up on OpenTX. And I was so happy because the YouTube expert said, oh, OpenTX is great. Oh, it's so great. It makes everything. And this guy talks about how he almost gave up on trying to configure OpenTX. And his honesty just made me so happy. I mean, I went out and bought him a $5 coffee. Oh. So get used to the idea, the experts with their bravado. Oh, this is super easy. Oh, you can get it done. I said, yeah, right. And Chinese brand components are a challenge. So you can lose a week of work because of a bad component. And sometimes you don't get any honest info about bad components. Now, SpeedyB is an example. SpeedyB products are like the rage lately. In fact, that's what I use because that's what all the videos talked about. I'll give you an example of problems I ran into. Here you see a picture of a connector. This is a connector between the two parts of the FC stack. If you look at this picture up here, you see there's a bottom part called the ESC and the top part, which is the flight controller. And you see this little ribbon cable here that connects the two of them. Well, I did everything I thought correctly to configure my SpeedyB controller, and it wouldn't work. I couldn't figure out what the deal was. I was ready to order a different one. And then I thought, well, I'll first look. I'll get out my magnifying glass. And sure enough, there was a problem. The plastic connector always had a faulty hole for the pin. And the pin had gotten bent. And the pins were so thin, I didn't even know it. And I thought, oh my God, the pin got bent into another one. It's probably ruined now. So I got in there with some tweezers and I kind of opened the hole a little bit, connected it up, and it worked. Yeah. So there's very little debugging help with all this stuff. Another time a pad came off. There's pads here, these pads right here. These are high voltage pads to the motors. One of them just started to come off from it. And then I bought a video transmitter, which when I got it out of the box, it fell into two pieces. Just fell into two pieces. I don't know. One of the experts who made a video had the same problem, and he said, oh, that's not a big deal. I thought, oh, right. It stopped working. This stopped working after a couple flights. But then I talked to people about this. I said, no, it's not a big deal. But then the experts, I talked to some experts in a forum, and they wouldn't believe me. But then I posted a warning from Amazon about this particular product here, about the flight stack, that it was a commonly returned product. And then the experts were silent. So anyway, this first page here is, how do you succeed in this? In building your own drones, you got to expect to spend a lot more time. Join a drone club. Use forums and websites. Look for specific instructions for specific hardware. I really think the way to do this is to find something like ZiptieAI that talks about a specific product and then buy exactly that product, a reference implementation. Because there are differences, and you're going to spend days, weeks, and I don't know. Or you might even give up. You can't find the problem. Document if you do anything special. And have the ZiptieAI mentality. If it doesn't work, try something else. I'll show you here on the right-hand side. I first started out trying to do Pixhawk. And I tried to do a Pixhawk Autopilot. I couldn't get it to work. I got it installed, everything okay, but I couldn't get the motors to turn. Later on, I tried to do Pixhawk. I mean Autopilot, AP, Autopilot. On the SpeedyBee, same thing. I couldn't get the motors running. I had no problem with SpeedyBee on iNav or Betaflag. Those are two firmwares, two types of firmware. But couldn't get it with Autopilot. And then for the Pixhawk later, I just tried PX4. Everything worked. I heard all this stuff. Oh, Autopilot's great. It's got a great community support. Yeah, right. I highly recommend avoiding Autopilot. And I'll get into that later, but I am not pleased with Autopilot. The documentation website also leaves something to be desired. So anyway, that's why you need ZiptieAI. And talk about why I created ZiptieAI. I wanted to organize my self-study material. I was in Ukraine. Ukrainian soldiers, it was impressive what they were doing, zip tying drones together. And AI. AI, if you lost the connection to the drone pilot, carry on without him, right? To me, this is the real future of a lot of drones is AI. And I had started out on AI before I got the drones. My real interest was AI. And I thought, hey, this is really interesting. And another reason was I wanted the satisfaction of creating a public-facing project that was 100% my own. The past few years, I've not had too much luck on projects I've worked on. Worked with some good people, but I got micromanaged on a few products. I wouldn't want to claim it as my own, and it's not public-facing anyway. So, I lost a job, a great, fantastic job where everything was very, very private. I lost that job because of COVID, and then I had I had a lot of contract jobs. So really just it's been a long time since I did a project of my own and to help others build and fly drones. And I don't know, be part of the community, I guess, the drone community. Also, I'm looking for a job. And so I thought I was also doing all this might help me to get an interesting job in the drone world. So the wiki organization, I'll try to get through this quicker now. The wiki organization, this home that I just showed you, and then we have getting into the air ASAP that you did in the previous video. Then we have the reference material. We have drone and AI concepts. That might be a little outdated, but just the basic concepts. What is AI? Not that important. And then a shopping list. This is important. So all the shopping lists, I did almost everything in Amazon. I had to get a few things and get FPV because Amazon didn't sell it. But all the information for what I did is all there. And I list what epic I bought this stuff for. RC means I bought this for the radio controller. And you can take this identification number and find exactly what I bought. So, and then tech overviews. I've only got one right now, but the idea, this tech overview for the radio controller. I couldn't find anywhere where they really explained how this all works together. The documentation on the radio controller, the experts don't understand the big picture or they're not talking about it. That's all I can say. And so I've put out something that I think is how it works. And then I'm going to make more of these for other aspects in the future, for different aspects of the copter. And this, by the way, this is the first configuration I used for my copter. Rather than building a copter in a scrunched up little carbon fiber frame, I just put it on plywood so I'd have more space to work on things, which turned out to be quite a good decision because that made it a lot easier to find that problem with that FC when I was configuring it. So tech overviews. What else? We have configuration files. Often I would see an expert explain how to configure, like, say, a controller, a flight controller. They go through all the steps in the UI, and they would never publish their configuration files. Everything you're doing in the AI is just to configure all the variables on the flight controller. Why do they never give their own flight controller configuration file and explain the parameters? Most of the parameters, a lot of them are customized to your drone, but a lot of them are not. So, and there's configuration files for a whole bunch of things here. The VTX, HTX, the Lua scripts, and all that stuff. So, and those are the references that, especially in the future, I hope to fill this out more. Right now, there's not a lot of configuration files. It's a little bit chaotic, I would say, but I hope to make it better in the future. Problem is, when you're like me, you're learning at the same time and trying to document, you end up redoing things quite a bit. So that was the reference. Let's go back here to the wiki organization. Now the rest of the wiki is six epics. I got 6 different epics. They're all here on the right side. There used to be 4, then there was 5, and now there's 6. I'll go through these quick then in this video. So the first epic is building the FPV drone, which you would have done in getting into the air ASAP. Then, and again, you start with the simulator. Then you try to do this with the SpeedyBee F405 with iNav. If you run into a problem, try Betaflight. And I'd avoid autopilot. But and then build, but this drone right here, our goal is to have an AI drone, but that drone's not really suited for use doing AI for several reasons. So, but you do need to get the experience before you try to do a PixHawk. Highly recommend it. So that's what you do in Epic 2. And again, you have 2 options here. And then in Epic 3, you add AI to the PixHawk drone. And here's, you have 2 different cameras, 2 different companion computers that do the AI. The companion computer here. And then you have 4 different combinations of the companion computer and the firmware. So if you have problems, you know, right now I've just done it for the Nano. I've not done it for the Pi, and I've only done it for PX4, not for Autopilot. Then Epic 4, here's the new stuff. So Epic 4 is about advanced AI. And there's basically 2 parts. Doing simulation, what's software and hardware simulation. Then doing the Mavlink API, studying that. This API, what it does is this Mavlink API. Let's see if I got a diagram here. Your flight controller, it allows you from your companion computer or ground control computer to send messages that tell your flight control unit how to fly the drone. And that's available on PixHawk. It's not available on the FPV drones. And that's why you can't do this on the FPV drones. So this is about, you first simulate. You want to know how to simulate first. Then you want to know how to write a more complex Mavlink program than what you did in the getting into the air ASAP. That was simply land, but here you want to get into more complicated stuff. Then getting into the various AI routines. Now there's a lot of AI routines because that is a list of what I did in the fall of 2023 before I even was thinking about drones, and I went through quite a lot of demos. It's maybe a bit chaotic right now, but right now it's the 5th of July. I go on vacation soon. My plan is, especially on vacation, to finally get around to start weeding out the chaff in all this and focusing on some good AI routines. Then we got Epic 5. Oh, I wanted to say also, this Epic 4 was the real focus. My real focus, what I really wanted to accomplish was getting AI on drones. That's my real focus. And here you see this picture of AI drones flying through a flying through a course, intelligent autonomous drones with no assistance. And this was, the university creates the first autonomous system capable of doing this better than humans. And that was, late in the fall of 2023. So it's very new. This is beyond what I go through in the AI, but still you get an idea of what you can do. So then Epic 5, we get into the advanced platforms. That's just a little overdone picture there. We don't get that advanced. But the idea here is you do the firmware development. That's where you change the firmware on the device. Okay, and I made, for example, I made a small change on PX4, compiled everything and then connected up, and then the firmware sent to my computer this information about the accelerometer. So that was pretty interesting. But here you're going to get into more advanced firmware development. What I did was just a simple example, just to see if I could do something basic. Yeah. And this is like a lot of things in ZiptieAI. You go through this right now, you're going to say, well, that's kind of incomplete. It's like, well, you're right. But I've only been on this for about 6 months, and I think and work big picture. So I like to plan out things in advance, and then so I know the direction, the conceptual idea and the direction. So then we have mission platforms. And mission platforms means basically specific missions like mine clearance, burst comms. That's something, an idea of mine. So we've got mine clearance, you've got target lock-on, lots of interesting. If you're a pacifist, which a lot of drone people are, you might not like this. Drone people, they have a lot of morals about dealing with the military. They really don't like dealing with the military, but they don't have any problems dealing with Chinese components, buying Chinese components. So that's the mission platforms. And then we have special projects. Advanced platform has special projects. Like I was trying to do a stealth. I was trying for one project to find a way to get all of the radio transmissions to go down a wire. I ran into a lot of problems with that because it's pretty complicated getting, for example, the radio controller, getting that stuff into a wire and not. And I was also looking into some other things, but that's special projects. So that was advanced platforms. So Epic 6 Pie in the Sky, it's an interesting title. Pie in the Sky means these are things I don't think really matter for ZiptieAI. I started out in this is the CITL that I started out with that was really helpful to me getting the big picture because there was no ZiptieAI. But this sticks only with, this is only simulation. It's not clear how you go from simulation to the actual device. These simulations are very difficult to set up, and this series is 5 years old. And these open source simulators do not impress me at all. I see very little value of doing this. There's also hardware in the loop simulation. That was originally what I was doing until I've got software in hardware simulation working. Here's software in hardware. This far fewer assets. I think it's a much better way to do things. This hardware in the loop is just confusing, too complicated. MATLAB. MATLAB, yeah, not impressed by their documentation. A lot of their stuff is old. You got to buy a lot of modules to do anything. They do give free trial versions. So I went through and did some stuff on MATLAB, but it's having trouble finding just a simple video that shows, here's MATLAB, you can do this, and you can work with this simulator. It's kind of like the the Citadel series. You know, they're showing these simulators all the time, but it's like, hey guys, how do I take this and go to an actual copter? And it seems like they're more geared toward robots. And robot is different to me than an intelligent copter. You got robot arms, they sit there, they do certain things, you know. Uh, so finally, ROS. ROS is called a robot operating system, and it's extremely complicated. The documentation is, yeah, not that good. I spent a lot of time on it. I think ROS is something that you would run on your companion computer so that you'd have a messaging system. So you'd have a camera, you'd have sending messages between all the parts on your intelligent copter, and it's a great idea. The problem is you're already trying to run AI on your NVIDIA Nano, and that's already complicated enough. How are you supposed to take something like ROS, run it on NVIDIA, and then run the AI with it? It's right now it's beyond my understanding. So anyway, that's why some of this stuff I call it pie in the sky. So it's like I still include it in here, but I don't think it's something I really want to spend time on. Again, maybe MATLAB for firmware development. Anyway, this is a long video, 26 minutes already. So that's pretty much what I wanted to give you was, you know, the basic why I created ZiptieAI, the organization and the reference, and an overview of the epics.